Now, something that is very fun and interesting to restore is an old TV set. Now, this is a 1949 television. I mean, this is from way back then. Black and white, small round tube, and let's see who it is. Teletone. Who knows? They're a lot of fun to work on. They're about the same as a radio, but they have just more of everything. The old main difference is you have the picture tube circuitry, whereas radio doesn't. Everything else is pretty much just amplifiers and stuff like that. Now, what we'll do is we're going to go ahead and restore this television and get it working. I have no idea whether this one even has a good picture tube. The first thing we're going to do is we're going to take it out of the box and we're going to see if the picture tube is good. I do have more picture tubes, but you know, it's just one of those things to where if you don't have a picture tube, you don't have the TV set. Alright, we'll get it out of the box. We'll take the screws out of the bottom one. There's only one screw in the bottom one. Oh boy. Okay, now everything is loose. Cord is peanut brittle. Save the plug. Cord goes in the trash. Alright, this should slide out of here. Something has been living in here. Look at this. It's been in the attic for 5 years, so whatever was living there is not alive anymore. If you pick one of these up out of a store or something, there's always a possibility of seeing something alive in it, so you have to be a little bit wary. Okay, there's the chassis. This is the tuner. This is the audio stage. This is the video IF. This is the sound IF. This is the high voltage generator for the picture tube. Alright, we're going to set this one aside. Okay, now what we want is to get the other chassis out of here. Okay, I'm going to set the box aside for now. Alright, now, there's our picture tube. There's all the guts. It doesn't look like it's been worked on. Alright. The thing we want to do, okay, here's 7JP4. That's a very common tube. I'm going to go ahead and pull the bottom off of it. And I'm going to take a meter. And I'm going to measure the filament. Now, on these tubes, almost all of these tubes, the older ones, the filament are the two pins that are adjacent to the alignment stud on the base. So we just set it to ×1 and measure, and we see continuity. So we got a good filament in the tube. That doesn't necessarily mean the tube is completely good, but at least we have a filament. About 90% of the time, if you got a filament, then you're okay. The tube's going to work. There are some times when you can have good filament, but the tube will be weak. You won't get much emission, and the picture will be dim. Now, these TV sets are exactly the same as a radio. 99% of the time, what goes wrong are the capacitors. So we're going to start off by completely recapping it. Now we're not going to do like we did on one of the old radios there and save the capacitors that are good. We're going to go through this one and we're going to take every capacitor that's the type that goes bad. Some of them don't go bad. We have disc ceramic capacitors. They don't go bad, so you can leave them in. We have mica capacitors. It's very unlikely that they go bad. But all of the paper capacitors, the high voltage capacitors, and especially the electrolytics, these filter capacitors, they all have to be replaced. Okay, they're using a selenium rectifier here to generate the power supply voltage. We'll go ahead and we'll use a silicon diode in place of that. Other than that, it's just a matter of a bunch of replacing capacitors. Now what I'm going to do first, whenever you get one of these sets, if you don't have schematics for it, which I do not, the first thing to do, take a piece of paper and write down the tube numbers and the positions. Just hack it out on a piece of paper. Okay, I'm going to start with the picture tube chassis here. I'm just going to draw a rough box. And a series string set simply means that all the filaments are hooked up in series and connected directly to the power line. Ballast is used to make up the difference in voltage. Okay, now that we got all the tubes out of there, I'm going to get a rag, wet rag, and I'm going to go ahead and wipe all the dust off of the chassis, and then a dry rag and dry it off. Okay, now I've got a wet rag and I've got a dry rag. Now, none of this is hurt by wiping it off with a wet rag. So just get all that dust, dirt off of it. Picture tubes are moderately hazardous, but only if you shatter them. Hit them with a hard object like a tool or something like that. So you want to be aware when you're working around a picture tube not to drop something on it or bang it with a tool, because it'll make a, usually they don't explode if you hit them, they just crack and that's the end of it. But I mean, it is possible for them to make quite a bang and throw glass around. So you don't want to break it. Okay, and then we'll just take the dry rag and we'll dry it off. Okay. That looks like it came right from the store. This one is a little bit more to do on this one. Okay, what I'm going to do, pull the tubes one at a time and mark down where they go. Okay, there's 1, 2, 3, 4, 5, 6 tubes on this one here. I might be able to find a schematic online for this, but we don't really need a schematic. These old black and white sets all have pretty much the same circuitry, and yeah, if you have an idea of how the stuff works, then yeah, you don't need a schematic. Alright, that's all the tubes out of this one. Got them all marked down. There probably is going to be a tube inside of here, maybe two. Oh boy, RF, look at this. It's an RF type of high voltage generator. Alright. Uses an RF oscillator. It's kind of like a tube type Tesla coil, and generates about 6,000 volts. Okay, we got our 1B3. Now, since this is an analog set, we will use a set converter, one of the converter boxes, the digital to analog converter boxes, to go ahead and generate a signal for it. It's no big deal. This one's had water on it before. Well, I don't know that it's water or whether it's mouse pee. There's really not enough of it here to say that it was underwater, but it's corroded in areas, and I would be willing to bet it was mouse pee. If that drained down inside the tuner, it could be very, very serious, but we'll just have to see. All right, that's got it reasonably cleaned up. Okay, that's the first thing that you want to do. Just get it cleaned up where it's nice to work on. Okay, the next thing we're going to do, get busy and start changing capacitors out. All right, now, since I'm just going to shotgun the capacitors in this thing, I'm not going to show doing each one, so the video won't be as long. We don't want to stretch the video out just showing cutting capacitor wires. Basically, all I'm going to do, take each capacitor and cut it out and put the new one in, and I'll just go until they're all done. All right, so I'll go ahead and get busy and replace it, and I'll show you the results after I get done. Okay, now the chassis is completely recapped. Now I tested these high voltage capacitors. These are 6,000 volt capacitors that are used in the CRT circuit, and they're good. So I'm going to go ahead and leave those in there. Now the filter capacitors, that was that big can, those have been replaced. All of the paper capacitors have been replaced, and the only thing left to do now is we'll put the silicon diode and resistor across the selenium rectifier. You replace it with 4007, anything like that. This is a 60 cycle diode, so it doesn't matter. Okay, now on these rectifiers, if you look very carefully at the surface, you'll see that one side has got kind of a rough coating on it, and if you turn it over and look at the other side, it's smooth. Okay, that's the difference between the side with the selenium on it and the side that is just bare aluminum. The side with the selenium on it is the plus side. In other words, that's the side that's equal to the line on it, on a diode. So when we put the diode in there, we'll put the line on the selenium and the other end of the diode to the end with no selenium. Now, a selenium rectifier has an inherent self-resistance of about 30 to 50 ohms. So this limits the inrush surge current into the circuit. If we put this diode in there, our inrush current is limited virtually by the line impedance itself. It can be hundreds of amps. So that can take your diode and blow it. So we're going to put a 22 ohm resistor in series with the diode. Doesn't have to be much of a resistor. A 22 ohm half watt resistor will do fine. Well, just by chance, I had a 22 ohm 1 watt resistor that just had some short leads. It will do just fine. And fasten it onto it. Okay. Now the last thing that I'm going to do on the chassis, which is a prudent thing to do, I'm going to just make a quick measurement of each resistor. Since this is a tube type circuit, there's a relatively small interaction of the resistors, leaving them in the circuit. Most of the time, the rest of the circuit doesn't affect the value of the resistor when you're reading it. In some places it does, and the resistor will read very low because it's going through other parts of the circuit. But what I'm going to do is I'm just going to go through and make a quick scan of the resistors, and I'm going to look for any resistor that is more than 10% high. We can't go low because it could be other parts of the circuit, but we can look for any resistor that is high. We should not have any resistor that reads higher than its value in the circuit. So what I'm going to do is I'm just going to go through and I'm just going to take the ohm meter and just read these resistors very quickly. And this is 47K and it's reading okay, it's reading very low, so it's got other stuff, okay? At least it's not open. Okay, this one here is a 51, it's reading 56, that's okay. 51, it's reading 54, that's okay. This is a 51, it's reading 52, that's okay. 220K, 207K, that's okay. 100K, 94K, that's okay. With them. Alright, here I have a 6.8 meg. I've got two resistors here that read virtually open. See, this is the kind of thing we're going for when we're just looking for them. We're looking for any place where a resistor is way over its value. Alright, here's 100K. This is a 1.5 meg. Okay, this is another one, 1.5 meg. It's bad. It's open circuit too. So these high value resistors, which actually are the ones that are most likely to be bad, have got to be taken care of. Okay, so we're going to replace two 6.8 megs and a 1.5 meg. Okay, that takes care of our two resistors. I had a 4.7 meg, 10%, and it reads high. It reads close to 6 megs, which is within what it should be. And then I had one 6.8 meg, 1 watt resistor. I didn't have any more, even though I got thousands and thousands of resistors. Those high value ones and stuff are rare. So that takes care of this chassis. Okay, this one here is ready to shoot the juice to. All right, we'll get chassis number 2 and start on it. Now, this electrolytic junk has to go. These are filter capacitors, they have to go. Okay, this is the high voltage box. All of these wax capacitors out of here. And then there's a few more wax down here. It's got maybe, it looks like maybe a dozen capacitors in the whole thing. So this is not going to be that big of a job either. And then we'll go through and do a quick check on all the resistors again. Alright, now we've got all the capacitors changed in here. Okay, we've taken the can capacitor and we've replaced it with a couple of the smaller ones that we just glued in there. And then there was another one, same thing. Now, we've replaced the line cord, and since this is a series string type set, it means 1/2 the line cord is connected to the chassis. Okay, this is not particularly any hazard, but just to make it as safe as we can, we arranged it so that the part of the line cord that goes to the chassis is the one that has the wide blade. Okay, we trace the wide blade and we see it's the one that has the rib, and we connect the ribs onto the connection that goes to the one that goes to the line. We find that the line goes to the switch and then directly to the chassis. So that's the one that we connect to the one with the wide blade, which goes in a typical wall socket to the ground. Okay, that gives us the best safety possible. It's not that dangerous anyway, because nobody's going to be reaching in there and grabbing the chassis while the thing's running. I mean, if they do, they would deserve to get shocked. Okay, I've also made a quick check with the ohm meter, gone through all the resistors and made sure that there are none of them that are off tolerance. I found a total of 1, 2, thought there was 3. There was 3 resistors that were off tolerance. They were like 50% off, and they should have been 10%. So I changed those out, and so now we're ready to go ahead and connect the sets back together, the two chassis back together, turn it on, and see if we can get a raster. Now, before we go ahead and put the chassis together, we'll go ahead and test the tubes. To do this, I'm not going to use an expensive tube tester. You don't have to have an expensive tube tester. This is a cheap little Sencor Mighty Mite 4, and it's an emission tester. It'll do everything we need to do to test these tubes. 99% of the problems in the tubes will be caught by this simple little tester. Okay, yeah, we'll start off testing them here. First thing we do is we set this thing, calibrate it. Okay. Alright, we're going to start with 6AL5s. I've got all the switches set for a 6AL5. Put it in socket 4. Takes a minute for it to warm up. I don't suspect any of these tubes being bad. Okay, the other one is a G. Both sections good. Okay, we got one. Okay, we got another one of them. Very seldom do you see the tubes go bad in these sets. It's really surprising. We just go through and test the tubes to make sure we don't have any bad ones. Save us some servicing headache. Alright, let's do an interesting tube. I've got a 1B3 high voltage rectifier. Let's see here what we have to do to get it tested. And socket number 1. Okay, we've got to hold this on there. It's good! Okay, I'll go ahead and check the rest of these and shorten the video a little bit. Okay, so now we're pretty much ready to go ahead and shoot the juice to it and see if we can get a raster. Okay, so first thing we have to do, the tubes are all tested. We've got the tubes tested, so they're ready to go back in. So we'll go ahead and take all the tubes, put them back in. Alright, there's one that goes in here. Yeah. Okay. Now, we've got 12SN7s, 25L6, let's see. 25L6 goes right there. Okay, and the Z5. Yeah, good. Really good. Okay, where's the paper? Tubes go. Okay, the ballast goes here. Got to make sure we get these tubes in the right hole, because if they're in the wrong socket, there will be trouble. It'll without glasses. Okay, 25L6. That's going to be over here. And now, okay, 12. 1B3 goes here. Okay, and that's another one. One left. It has to be the one in here. Okay. We'll see what happens. Okay. Now, we have a whole bunch of little bitty tubes. So 6AL5 goes right here. Okay. AL5, third one in. Okay, 6AU6s of those two. That's one. All right, now that gets all of our tubes in the way they should go. Okay, now this has to go back onto here. Okay, now this one gets plugged into here. This one into here. Okay, and then this one right here goes right here. Okay, now that gets the whole thing hooked up and ready to power up. Now what we're going to look for, we're just after the Raster right now. We're not after a picture. We don't have the signal hooked up yet. Okay. Okay. Here goes. Here goes. Sorry. Blew the fuse. Okay. Okay, I'm going to set it up a little higher. All right. Okay, we're pulling about 100 watts. I have an electronic fuse that I have in all my bench stuff, so if something shorts, it turns that electronic fuse off immediately. It saves things from blowing up. Ooh. Well, for a second there I heard vertical sweep. I don't see. No Raster. Okay, I don't know what the... Let's see. Okay, we're not getting any high voltage, and the high voltage tube is not lit up. Okay, I can test the high voltage by bringing this here. It's completely dead, so I'm going to cut it off. Okay. Now, looking through all of these tubes, all of the tubes were 12SN7s except for one. I suspect that this was supposed to be a 12SN7. Maybe somebody did not have a 12SN7 and they put a 6SN7 instead. There is a 16SL7 in there, but all of these others are clearly marked 12SN7s. The only one that's not marked is this one in here, and that was the one that was this 6SN7, and I suspect that is wrong. I'm going to go find a 12SN7, and we'll see if that fixes the problem. Okay, that gets a 12SN7 in there instead of a 6SN7. Alright, here goes. Okay, power's on. It's lighting up now. That tube is lighting up. That's the high voltage oscillator tube. Let's see. Oop. Oh boy. Yeah. Pulling arc. I see something on the front. All right. Okay, we got vertical, but we don't have any horizontal. No horizontal. Okay, so we've got something. Let's see. Okay, now I've got it set up here on the bench. Okay. When I go through and I measure with the scope, it's not the horizontal we're missing the vertical. And what I do is I am checking the B+ on the tube, and I find from the schematic here, we measure on the vertical oscillator tube and we have no voltage. Alright, so I see where that's coming from, and it's coming from this electrolytic capacitor right here. And when I measure on that, there's no voltage. So where does that get it? If we look on the schematic, we find there's the ballast, which is right here, and we should have between 1 and 2, 16 ohms, and we've got that. Okay, if we measure between 2 and 4, we should have 220 ohms. Power's off. We don't have anything. And then between 4 and 5, we should have 220 ohms again. And we don't have anything. So we have two sections in the ballast that are burned out. They're 220 ohm resistors, and they're carrying a lot of power, so they have to be power resistors. Alright, so what we're going to do is we're going to open the ballast and take a look at it and see if we can see the problem. Like zero chance. Okay, we just take these and we just pry these little crimps here. You just take a pair of small cutters and just pry them out so that you can get the case to come loose. Now we should be able to pull this out of here. Oh, there we go. Alright, and there's our ballast. Holding it about there. About there, it'll show up little. Okay, it's hard to do because it's fine wire. I'll hold it about there and hope it shows up. Okay, that heavy piece is the pin 1 to 2. Okay, that one there is intact. Alright, then we have from 2 to 4. Okay, now that's one of the inside ones. There it is. Okay, see right here? Okay, and there's the loose wire, the broken wire right there. Okay, I'm going to stretch that out. Here's the one that goes to pin 4. Okay, pull that down. I don't see that I'm going to be able to fix this. It's like trying to wrap two little pieces of hair together. See, I need to wrap them together. Okay. This is pretty much a lost cause. So what we're going to do, we're going to get some power resistors, and we're going to solder them onto there and use power resistors. Alright, here's our replacement for the ballast. What we've got is two power resistors, we got a 10 watt and an 8 watt. And they're going to be used to replace those two that are burned out in the ballast. Okay, this will do just fine. Now, pin 1 and 2 I eliminated because we have that resistor now outside and we don't need it anymore. So I'm going to take pin 1 and 2 on the ballast and I'm just going to connect them together. I'll just take the wire off of pin 1 and I'll just put a jumper, it's good enough. We'll leave it. If somebody finds a ballast later on, they can put it back in, make the thing original again. So I'll just put a little jumper between pin 1 and 2 and that'll get us all back in shape working again. Okay, now that's going to get us some voltage onto our vertical oscillator, and probably 3/4 of the rest of the set too. All right, now I'll go ahead and shoot juice to it. Uh-oh. I'm not seeing any current. I'm not seeing any current. Okay. 1, 2, 4, 5. 7. 1, 2. Something else needs to be jumpered. Okay, it couldn't have been that easy, of course. Okay, let's see where pin 7 goes. Pin 7's got something too. Okay. 1. Pin 7. 2. Pin 7. Let's see where pin 7 goes. Okay. Oop. Goes to 6. Okay. Alright, 6 and 7 have got a resistor in it too. This is not shown on a schematic, it's somewhere else. Lost. Okay, that is a 20 ohm resistor between 6 and 7. Alright, so we got to have that in there too. Okay, no problem. We'll do it. That's a filament dropping one there. Alright, I'll get a 20 ohm resistor and we'll put that in there. Alright, here is the end result of our ballast replacement. A total of 5 resistors on there. You can see now why they put it in there. Well, we're not that much bigger than a regular ballast, but whew, that's a lot of soldering to do. Okay, let's see what happens. Everything's off. Okay, we've gone ahead and completely recapped the unit, tested all the tubes, and put a new line cord on it, and let's see, what else? That's pretty much it. Tested a lot of the resistors, but seeing that there's another resistor that has a problem. So the centering has completely gone off on the Raster. We do have a Raster though, everything's working, and we do have a Raster. So tomorrow we'll go ahead and go through the high voltage resistors. There's a string of high voltage resistors that sets the centering on it, and these resistors tend to drift a lot with age. So I suspect that's what's happened here. The resistors are just, you apply power to them, they warm up, and then they drift. So they might read correctly when they're cool, but then when you go ahead and apply power, they drift. So what I'm going to do is I'm going to go through and all those high voltage resistors, I'm going to go ahead and shotgun those out too, because it just isn't worth fighting it. Trying to find which one is drifting. Okay, and then tomorrow we'll go ahead and once we get a good raster, we'll go ahead and put a signal into it and see if we can make it have a picture. Okay, now, it turned out, okay, what we've done to the set so far, we have removed all the capacitors and replaced them. It turned out these high voltage capacitors that were in there were leaking, and that was what was causing the offset on the position of the vertical or horizontal, because it's the thing's laying on the side. It's because these capacitors were leaking, and that was causing it to shift over. So replace them too. So that makes all the capacitors except for the disc ceramics and the micas have been replaced completely. Okay, resistor wise, about half of the resistors in the bleeder string for the picture tube were way off tolerance. Those were all replaced. Ballast itself, all the resistors in the ballast were replaced. Handful of resistors in the rest of the set were replaced. Okay, the result is we have a good solid Raster. Very stable and has no tendency to drift or change. Okay, the next thing that we have to do is we have to get the set converter, the digital to analog converter working. We've got one. It's a little RCA unit, little bitty box, and we'll go ahead and hook that up and make sure that we're getting a signal. And then we're going to connect it to the input and see if we get us a picture. Alright, now we can turn this off for the time being. Okay, I've got a little solid state monitor that we use to tell that it's working. Okay, that gets us an antenna. Now, I don't know how we work this thing. A lot of this stuff is made to where it's extremely complicated to get it going. Okay, it's doing it. Okay, we got some channels. All right, now it's still scanning. All right, we've got us a channel, and we look at the spectrum analyzer, and we see our output, and this is showing right at 66 megahertz, which is, I think, channel 2 or channel 3. I don't know which one it is. It's one of those. That's going to be our analog output to the TV. All right. Well, let's set her up and see what happens. All right. We've got the set-top converter connected up with a little coax onto the back of the antenna terminal. And we'll go ahead and fire it up and see if we can adjust it to do anything. I don't know. I really don't know. Zilch. All right, we're getting absolutely nothing. Okay. Now, what indicates that the set is completely dead is that the speaker itself is not giving us anything either. When I turn the channel switch, we should get some crackling and scratching in the speaker, but we're not. The speaker's good because I can put my finger on it and I can feel a vibration of 60 cycle hum from residual power supply, but there is no no actual signal at all. Okay, so what we're going to have to do, we'll take the set and get it set up to where we can start running a signal in, and we'll see if we can find where the signal is dead. All right, I've got it set up here where we can work on it. Now, if we look at the schematic, very, very straightforward. We have the tuner. Output of the tuner goes to the video amplifier, which is right here. Okay, at the last video amp we have a takeoff for the sound, and we go to the sound amplifier and detector, and then we have the sweep circuits, which we already have working. All of this stuff down here we worked on yesterday. So today we're going to work on here. We're going to try to get a signal. We'll put a signal on the input of the first video amplifier, and we're going to see if we get it on the output. Now this one here, it's marked 36.9 megahertz. It's an oddball frequency. 45 is what the more modern ones are, but it doesn't matter. Now I want to give a very quick little discussion about test equipment and line operated equipment. Now, all of the test equipment that you see when you buy it has a third wire going to ground. This means that the chassis of all of these instruments, if you don't do anything, is at ground potential. Now, if you plug your power cord on your TV incorrect, you're going to be okay. This will be ground, and it'll be ground and ground. Now, if you by chance get it backwards and the chassis is hot, you could have 120 volts between your scope ground lead and your chassis. So you want to keep this in absolute consideration whenever you're working on a piece of line equipment. Make absolutely sure that the plug is in the socket correctly to have ground on your chassis, because not only can you get a heck of a shock, but you can blow your little ground connector off of your scope. If that's going to 120 volts, it'll just poof and blow that thing to pieces. I've seen it happen before with people that got careless. Okay, now we're going to set the signal generator. Okay, 39.4. I think I can get it with this one. I'll try. I got several signal generators. 8. We get 39. We're not getting to 39.8. 39.8? 39.9. 30? No, 36.9. No, there's plenty of room. Plenty. 36.9. Okay. 37. Okay. 36.82. Good enough. Okay. Now. Okay. This gives us a signal. And on a 6AU6, I think pin 1 is the input. Okay, I'm going to set this to a little bit less signal. I got about 4 or 5 volts coming out of it right now. And we're going to just connect this onto pin 1. 12K resistor. Yeah. I'll put the camera over on the scope in a minute whenever I get a signal and show what we're really getting. Right now I'm putting a modulated, let me show you that. Here's what I'm putting into the input. Okay, the carrier is 36.9 megahertz, and this one here is it's just variable. It's got another signal generator here that for the modulation. Okay, and that'll just give us a signal. Let me give it a little bit more gain here. There we go. Thoroughly modulated. Now that signal, since the signal from a video transmitter is AM, this kind of a signal will go through and let us just trace through. If we had us a television signal generator, then it would have a set of signals for doing this. But I don't have any of that kind of stuff. It's kind of specialized, and I don't think I've restored one of these sets before. This is the second one, and third one. I did one for somebody, so it's 3 sets I've done, and compared to over 1,000 radios. So I have lots of stuff for radios, but I don't have a lot for television because I don't do very many of them. Now, what I've done is I've connected the signal generator onto pin 1 of the tube. Okay, I think I can get away with that. I may have to use a capacitor, but 120 ohms. See, it's getting feedback there. from the AGC. Okay, we're not worried about AGC. See, it's AGC feeding back there. By connecting the signal generator, which is 50 ohms, onto there, we're shorting out the AGC onto the stages. We don't care about the AGC right now. We just want to see signals coming through. Okay, I'm gonna just first, I'm gonna go on down here to V8. This is the last video, and I'm gonna see if we have a signal there. If we do, no trouble. If we don't, then we'll troubleshoot through it. Okay, that is V8. Okay, we look on here, and okay, V8 is the second one. Okay, it's right down here. Now I got to watch out. This has got 120 volts on it, plate voltage. So, you know, I can have some fun here. Now, when you're troubleshooting these things, always use a ×10 probe. Do not use a ×1 probe. If you got a switchable like this, make sure it's set to 10 times. You want it to be the lowest load on the circuit as possible. Alright, and we're going to go for the plate on that thing, which is pin 5. 2, 3, 5. Okay, that looks good. Okay, nada, nada, nada. We're getting a straight line. So somewhere in the conglomeration here, we're losing the video. Okay, I'm going to just trace it through. Okay, the first one I'm going to go to the grid of the second video. That'll give us, see if the signal's getting through the first one. Okay, that's pin 1 on the second video. Okay, these just go right down the string right here. And I'll just connect the scope onto it. Okay, 33.5 is where our maximum is. Okay, let me show you the signal. Okay, as we vary the frequency, we move off of the resonance, okay, and alright, and that is at 33.2 megahertz. I'm not sure, I have to read the alignment instructions for it. I'm not going to mess with any of the alignment until we get everything working. Okay, so that's on the grid of the third amplifier. Okay, I'm going to now go to the grid of the last amplifier. Okay, we don't get anything at all. So we're losing it in the video detector. Okay, now video detector 6AL5, it's just a diode. What we'll do is we're going to look on pin 1 of the diode. We should get the signal there. Okay, and here we are. Get nothing. Alright, that's pin 1 of the amplifier just before the detector. Okay, I should be able to move right over onto the pin 1 of the detector and see it. Okay, we got good signal on the grid. We got nothing whatsoever. Okay, on the grid we got good signal. On the plate we got nothing, nada. Okay, I'm going to check the voltages on this tube and see if they're good. Now we know the tube is good because we already checked it. Okay, plate voltage is pin 5. 1, 2, 3, 4. Alright, we got about 100 is 50 volts per division there. So we're reading about 100 and maybe 10 volts. Okay, that's fine. Next, we're going to look at the screen. Okay, it has to be correct. Pin 6. Alright, same thing. It's got a coil across it. Okay. and then 7. Okay, goes through 82 to ground, and it has nothing on it, and that's correct. So everything looks correct here, but we're sure not getting any signal. Okay, I think I found the trouble. Okay, just for the heck of it, I was looking at it, and I was going to take the 6AU6 and test it again, and I pulled the tube out. It's a 6AT6. Well, I see here on here, when I marked this drawing, I marked it wrong. Now I pulled them out and marked them directly, so somebody else had worked on this and they had gotten the 6AT6 and the 6AU6 mixed up. So I've got to pull that 6AU6 out of there and get it. I got everything shut off, and okay, and we put this one in there. You can't have the wrong kind of tube in a socket, that's for sure. Alright, all our wires are hooked up. Here goes. A 6AT6 is a triode, and a 6AU6 is a pentode. So, not the same type of animal there. Aha! Now we get changes. See, we hear the noise in the speaker now when we change the switch. Alright, now let me see if I can get this cable hooked back onto here. We're getting some signal okay. I mean, it's picking up. I think we got success. Okay, let me get a screwdriver. Well, we've got it all the way up to the video, but we're not getting any video to the screen. The video driver's not right. All right.
Good night, Peggy. Good night, Joe. Good night.
Well, I got things to do, so tomorrow we'll get after the video driver. Okay, you've got the thing set up again. We're going to look through the video circuit, and we're going to see if we can see what's going on. I suspect that the video detector is not working correctly. Okay, the first thing we're going to look at the video signal itself, which will be right on this point here. The cathode is what's driven by the video signal. Okay, that is a wire with a wire to the picture tube cathode, and that's the video. I'm just going to connect to that. We're on the 10 volt per scale, 5 volt per scale here. We're getting about half a division. That's 2 volts per division, about 1 division. We're only getting about 2 volts peak to peak on the video. It should be 10 times that to drive this picture tube. Now, adjusting the contrast, we're at full blast, so it doesn't make any difference. Alright, so something is killing our gain of our video. Now, I was going through, looking at the voltages here, and I see, if we look on the plate of the video amplifier, we have negative voltage. That is absolutely totally wrong. The plate has to be positive. Okay, I look over here on where it's getting power supply, and we've got a 6800 ohm resistor here. There's plus 120 volts on it. But I look on the plate, there's nothing. So I checked this coil here, L12. It's a little peaking coil. It's open. Alright, we're going to cut that out of there and see if we can fix it. Otherwise, we have to find out what it is and replace it. That looks like it's the problem with the set. Alright, we'll cut that out of there. Okay, power off. Okay, it's a 22K resistor with a bunch of wire wrapped around it. And if I measure it, it reads 22K. Well, no. It reads 200K. It reads way up there. Okay, so somewhere we got a break here. I would like to salvage it because we have a certain inductance that it needs to be. I don't have any idea or any way to tell what it would be. Okay, I'm going to find each end of the wire. Usually when these things break, found it. Okay. It broke right on the edge. Real fine little wire here. Measure from here. Aha. All we have to do is connect this back onto here, and that takes care of the break. Probably heat did it, probably thermal. No way of really knowing why it went, but thermal would be the most likely cause for it to burn out, to break. All right. Okay, after doing a little more poking around, it turns out that there was a filament to cathode short on the horizontal phase detector tube. Not a heavy short. It wasn't enough to show up on the tube tester, but it had a leakage that was reading about 30 kiloohms. And that was enough to cause some 60 cycles to get into the phase detector, and that caused it to completely not function, and you couldn't lock in the picture. Okay, so now we've got a solid picture on it, and I'm going to go ahead and just move it back over onto the table, and we'll see what has to be done next. Okay. Now, we've got the picture on it, and we check our... There we are. I'm going to put this down a little bit. There we go. Okay, so this gets our picture. So the next thing that we'll do is we got to get the cabinet ready. Alright, what we've done so far, okay, we've replaced all the capacitors. We've replaced one tube that had a leakage in the filament. We remade the ballast. We replaced a bunch of resistors. And other than that, that was pretty much it. I did a little bit of adjustment. Okay.
No, not quite yet, Jerry. Every time I think I got you figured out, you do something to confuse me. You know, maybe you want to get a slant on my personal life. I got one, you know.
Now, if we look at the front of the tuner, we see that we have numbers 1, 2, 3, 4, all the way up through 13 or 12. 13 or 12? Okay. This one goes up through 13. Okay. This TV converter box has its RF output on channel 3. So what you would do, you set your fine tuning to the center of its range, and then you go in on channel 3 with a non-inductive screwdriver. A plastic one has a little screwdriver. Some of them use a little hex, but this one here uses screw. Go in on number 3, and you just adjust the slug in the tuner until you get a perfect picture with the fine-tuning control in the center of its range. Okay, that way you have maximum range of tuning either direction. Okay, we've got it set correctly now. Okay, other than that, unless you suspect the alignment of being off in the set, seriously, don't mess with any of the alignments. Leave it all alone. chances are it's all as close as you're going to get it without having an alignment generator. It's very difficult to set the alignment of a set without using a proper alignment generator. If you try to do it using a picture on a screen, you're going to get it so screwed up that you're going to have a blurry picture, and it's just not going to be worth doing. So the whole key is don't mess with anything except the tuner alignment if you suspect that it's off. Okay, one of the things that'll tell you that the alignment of the tuner is off is if your fine tuning is off way at one side to get the picture proper. The fine tuning should be right in the center of its range when you get the best picture, and that you just adjust the control on the tuner to get that if it's not correct. But don't mess with any of the IFs, don't mess with anything else, leave those alone. Okay, now let's see what we have to do to the cabinet. Alright, now the front of this cabinet is a brass plate. They have a neat brass plate on here, and I think that that will look beautiful if we polish it up. The cabinet itself is a made out of wood that's covered with this leatherette, fake leather cloth. Not much we can do on that other than just completely clean it up. And what we're going to do is we're going to clean it up totally, and we're going to stain it and then spray it with lacquer. Alright, let's go ahead and we'll move it out to the shop where we can do this a little better. Okay, now first thing we're going to do, we're going to go ahead and take the front off of it, and let's see, I ought to have a little a little thing to put the screws in. Loose screws. This. Okay, and there's our front, which we're going to clean up. It's etched, so we don't have to worry. It's going to be easy to clean. Okay, and here's our piece of glass. Clean that up good. It's a piece of safety glass for keeping you from breaking the picture tube. Okay. Now, the cabinet itself, okay, I'm just going to leave, yeah, let it come out. Okay, that's our speaker grill. We'll just go ahead and clean that up and make it look good. Okay, now, first we're going to take the cabinet and we're going to wash it down. We got to clean it up so it looks good. Okay, I got spray cleaner. This is, I think it's 409 or Fantastic. It's one of them. It's just a spray cleaner. I'm just going to spray a little of that on there. And damp rag. This is just to get dirt and grease off of it. Okay. Okay, set that aside to dry. For this, we're going to buff it up using steel wool. All we do is we take fine steel wool and we start polishing. Alright, it's going to take more than that. Let me get some sandpaper. We're going to use some fine sandpaper first. Alright, 220 grit sandpaper. I'm going to use that just to take the dirt off of it. I mean, the thing is just absolutely corroded completely. Okay, now this gets our our piece nice and clean. We don't have to bother with the back. All right, now the next thing we're going to do is we're going to take 4/0 steel wool. This is the finest steel wool, and we're going to buff it. Oh, does that look nice? .220 grit leaves a little bit of a sanding line in it, but not bad. They don't have to all be out. The sanding lines will blend in, and you won't see them. You won't see them once we're done. I'm going to show you what we do to make it really look great, and you will not see those sanding lines. But right now we're just buffing it to get it really shiny. Now, there's another look that's also very good on this, and that's the mirror finish look. You take a power buffer and polishing powder, polishing compound, and buff this until it's absolutely like a mirror, just like a brass mirror. And then you coat it with lacquer. And I mean, it looks really sharp. Now this one we're going to do antique. Okay, so what we're going to do is spray it. Okay, we've got this thing buffed down to where it looks very nice, okay? All right. Okay, we've got the front panel completely polished up satisfactorily. Now we're going to color it. We're going to put a patina to it, a dark patina. And to do that, we're going to use some stain. We're going to use just plain old wood stain. Now, I've got spray stain that I'm going to use, but you don't have to use spray stain if you can't find it. The spray stain is a little bit expensive and hard to find. Okay, this is a dark walnut. I'm just going to hold it back, and I'll just put a light coat. Okay, now I just take my finger and I'm going to just give it a grain. All in the same direction. All right, now we're going to let that dry. We're going to go over it a second time to darken it up even a little more. But see how it's giving it a golden color? It's very beautiful. Okay, now our cabinet, the cabinet looks atrocious. So what I'm going to do, I'm going to stain the cabinet. Now this handle looks atrocious here, so I'm going to take it off and we're going to refinish that handle to make it look better. Okay, this part here we're going to spray with black lacquer. This is just ordinary black spray lacquer. I'm just going to put it, darken it up a little. You can buy new ones of these. I think Antique Electronics has them. They're used on guitar cases and stuff like that. So you could buy a new one, but this one's in good shape and it's original, so I'm going to just keep it. Let that dry, and afterwards we're going to put a lot of lacquer on it to shine it up. Okay, now this is a little rough up here, so I'm going to take the sandpaper Okay. Okay. Okay, now what we're going to do is we're going to stain the cabinet to darken it up a little bit. Okay, this is just Minwax Colonial Maple. It's not a dark stain. It's a stain that's light, almost the same shade as what the cabinet itself is. Now, by going over it with the stain, it's going to even out the color on it and make the cabinet look really nice. I just have a little piece of felt. If you have a rubber glove, you can keep your fingers from turning brown. This takes all the scuff marks and things like that and blends them in and makes it look even. Okay. Now, that gets our cabinet completely blended and evened out. Now, we want to leave this sit overnight. If you've got sunshine, you can put it in the sun and you can dry it in a couple hours. But if you don't have any sun, like today, there's no sun, so we have to leave it overnight. And tomorrow we'll go ahead and finish it. All right, back to this one. Okay, we want to take this one. We want to go a little bit darker on this. It's good right now. It would look fine the way it is, but I like them a little bit darker. Okay, that looks good. Set that aside. Okay, we'll let that dry, and then we're going to coat it with clear lacquer to make it shiny. Okay, next we have our channel selector dial. We're going to do the same thing to it that we did to the other. We'll take the sandpaper. Okay, see that's our dial. Be a little on the outside. The outside we don't need to do a lot on. We can leave it a little dark and it'll make it look good. Now, what I'm going to do is I'm simply going to take Jacobine. This is Jacobine stain. It's a dark, kind of a dark gray. Gives a really nice patina to brass. Okay, I'm just going to take a little of that. Look at that. Isn't it beautiful? Oh, no, let me... I guess that shows. It's hard. I'm so blind I can't tell even by looking in a monitor whether it's focused or not. But that, see how nice that looks? Now that's just polishing it to brass and then using Jacobine stain. Now once that dries, we'll coat it with clear lacquer and it'll be just a beautiful dial. Okay, now we have our speaker grill And we're going to do the same basic thing to it. I'm just going to wipe it off. And I'm going to use the Colonial Maple on it. Okay, I'm just going to take Colonial Maple and just slop it on there. Okay. Saturate it good. That's good. Then I'm going to take a rag. I'm going to soak up the extra stain. We're just coloring it. We're not saturating it to the point of being just wet with it. Okay? All right, that gives us our grill. We'll just let that dry, and then we'll spray it with lacquer. Now, these things, they're atrocious looking. I don't know how to clean them. Okay, I'm going to try the lacquer thinner first. I'm just going to take them and I've got some lacquer thinner in here. I'm just going to put them in the lacquer thinner. And, well, there goes the fingernail polish. And we'll see if it soaks up that, whatever that coating is. There's some kind of coating on there they put on there. But we're going to make it just plain chrome. Okay, that's going to do it for today. We have to let this stuff all dry, and then tomorrow we'll go ahead and spray it with clear lacquer and assemble it. Okay, it's been another day. This is the next day. We're completely dry, and it looks good. What we're going to do now is we're going to spray it with lacquer. I've got the spray gun filled with clear lacquer, and we'll just go ahead and spray it, and that's going to finish this cabinet. And then we'll spray the front panel and get it done. Okay, I'm spraying using 30 pounds of pressure, and we're just going to put it on there. Now, when you're spraying the lacquer and other things, you want to either wear a face mask or do like I do, have a tremendous circulation of air flowing through. You can't really see it in the camera, but there's a big fan on the other side, and the air is circulating past and out the door. So I don't breathe any of the fumes. The fumes are going out the door. But if you're in a closed area where you don't have circulation, you want to wear a paint mask to keep the fumes out of your breathing area. Okay. We'll put a little bit more on the front. That's it. Oh, that looks good. It gives it just a little bit of a shine. Okay, here we have our front panel. Make sure there's no dust on it. Tuning dial. Okay, we'll let that dry and then put another coat on it. Alright, while that's drying, we'll go ahead and put the handle back on. When you get one of these old sets that has a handle like this, you want to make sure the handle is in good shape. There's nothing that'll be more aggravating than to have the set all restored, and you pick it up by the handle and start carrying it, and have the handle give way and have it fall on the floor and smash the picture tube or something, and just all your work is for nothing. If the handle has any tendency to be rotten, you just buy a new one and be done with it. Okay, we'll put the final coat on the front panel and the tuning dial, and then we'll let it harden and put it together. Okay, we'll let it harden for several hours. Okay, we're going to go ahead and assemble the front panel. Alright, we've got this unit here, which is nice and clean. Just make sure there's no fingerprints on it. Okay, that goes in there. Okay. And we got the little bitty screws. Okay, now we'll go ahead and put the speaker grill in. That goes right back into here. I'm just going to go with the heat glue. Alrighty. Now we'll just take it all inside, and we're going to put the electronics back in. We're done. Now, we're going to go ahead and put the chassis in. The first one we're going to put in is the side one, because it has an overlap that has to clear. We can't get the bottom one in we can't get the top one in if we do it last. And okay, that gets our top chassis in. Okay, now we'll slide the bottom chassis in. Okay, now. Okay, now, the next thing we do, okay, we take this connector here, and it goes right here. Okay, and here's our video connector, goes right here. And our high voltage connector, it's right here. Okay, that comes down, goes into there. Okay, and then we got these two here, and the antenna gets connected onto here. See, and fancy antenna. Isn't that cute as can be? What they think of. It's original and it works, so we'll leave it there. Okay, now we'll hook converter box. Okay, that gets our converter box. I'm not going to mount this in this TV because I have another TV I'm going to do as well, and I'm going to need it. Okay, so there we have it. We got the TV put back together. Got a picture on it. Let me see if I can get a little more height out of it.
Your vision holding you back from living life to its fullest. Now is the time to discover LASIK at TLC Laser Eye Centers. At TLC, we're North America's most experienced LASIK surgery provider. For over 20 years, we've performed 2.2 million eye surgeries and helped over 1 million people improve. Just a sample of what many of our satisfied patients have had to say about their experience at TLC and how life-changing corrective eye surgery has been for them. With TLC's highly experienced LASIK surgeons and state-of-the-art clinics, we can improve your vision through quick, convenient procedures that are safe, affordable, and most importantly, life-changing. We're so confident we can help you see better. We stand behind our results with our TLC.
Alright, we got it all working. It looks beautiful. The cabinet looks great. The front panel looks great. I'm missing one knob, which I'll find another one of these days and put it on there. But other than that, it turned out beautiful. Works great. This is what you do to restore an old TV set. Now, what we did, first off, we replaced all the capacitors. Okay? Now, we can leave the disc capacitors and we can leave the mica capacitors, but all the rest of them, all the paper capacitors have got to go. We found that out because of the problems we had here. Okay, second, we check all the resistors. Go through and just ohmmeter each resistor using a digital voltmeter and digital ohmmeter, and just any resistor that reads more than 10% off, 20% off, so replace it. Okay, we replaced about, I'd say, 10 resistors total in here. Okay, the ballast had to be replaced. It had to be remade. You simply take the schematic, look at the values of the ballast, and just take power resistors, get 10-watt power resistors, solder them to the right pins on the connector, and make another ballast that goes in there. Okay, we then that's pretty much everything that we did. We set up the tuner by taking the screwdriver and adjusting the channel 3, which is where the set tuner comes out. These set tuners will be either on 3 or 4, channel 3 or channel 4. This one's on channel 3 and you can't change it. So we just set the tuner here on the TV set to channel 3, and we go ahead and tune that to where it's perfectly adjusted, and that makes it to where we have a good picture. Okay, then other than that, we just put it all back together, and it's working great. That's it.